JoJo.
And I'm Kate, and we're here on our first episode of
Stats Rocks. The title of our project will be
Lions,
Tigers,
and Statistics.
Oh my! In our statistics project, we intend to analyze the true population mean differences between the age of the Woodland Park Zoo visitors. Our null hypothesis being the true population of kids is equal to the true population mean of adults who visit the zoo, and our alternate hypothesis is whether the population mean of adults ages 13 and over by the zoo's definition visiting the zoo is greater than the population mean of kids ages 3 to 12. The purpose of this study is to conclude whether the population mean of adults visiting the zoo is greater than the population mean of the kids visiting the zoo. This is important especially for the analysis by the media team of the zoo, to decide whether to target a younger audience in their advertising or an older audience, so they can ensure the most revenue. Also, this could be helpful to realize who they attract more on a monthly basis and who they sell tickets to.
We've gotten our data from the Woodland Park Zoo itself, contacting Jessica Patterson, the Associate Director of Guest Services. She and her staff compiled the attendance figures for the zoo. So we asked for data from 3 random months, and she got back to me a few days later, sending me 3 separate spreadsheets from March, April, and May of 2017. And what she does is compiles the data each day of the amount of adult visitors and the amount of children visitors that visit each day, and she was able to pass that information along to us.
What's up, guys? We're here today at the Woodland Park Zoo, and we're gonna ask some visitors whether they think more kids or adults visit each day. Let's see.
On average, do you think more kids or adults visit the zoo daily?
I would say kids.
Okay.
So if you had to guess, do you think more kids or adults come to the zoo each day?
I would say more adults because they bring along groups of children and they'll only have like 1 or 2 supervising the children.
I would say probably more adults, but I have no clue.
And I'm disagreeing. I think there were a lot more kids here
A lot more
today
kids?
anyway.
Okay, thank you.
I would say adults.
I would also say adults.
Okay, thank you.
Kids.
Kids?
Adults.
JoJo and I chose to do our project based on the Woodland Park Zoo because the Woodland Park Zoo is a really popular tourist attraction in Seattle, and we both grew up here our whole lives, and it's like a place that's special to both of us in our childhood. And I also had the chance to intern here last summer, which is a really rewarding experience, so we're just really happy to be here.
So we plan on carrying out a 2-sample t-test where the null is going to be mu1 is equal to mu2, and the alternate hypothesis is going to be mu1 is greater than mu2, where mu1 is going to represent the true mean population of adults that visit the zoo, and mu2 is going to represent the true mean population of kids that visit the zoo.
Now we're going to carry out the conditions to make sure that it is appropriate to carry out our 2-sample t-test. So first step, we have randomness. And we do know that it's random because we're randomly selecting 30 days from the hat.
Okay, so this is our randomization part of our study. Basically, in this hat we have 92 slips of paper that are all the days of the months March, April, and May that the lady gave us. And on these slips of paper it says the date and how many kids and how many adults visited the zoo that day. So what we're going to do is we're going to mix them up, and then I'm going to randomly pick a slip of paper, and it's going to tell me how many kids. So for example, this one's 576 kids and 1,316 on April 3rd. So that's just an example, and I'm just going to pick 30 more for our for the sample size for our study.
Next up, we have the 10% condition. We do the 10% condition to make sure that there's independence. So the 10% condition states that little n1, since we have two samples that we're taking from, is less than or equal to 1/10 times n1, and we have n2. So basically our sample for each n1 and 2 is 30. Which would become n1 is greater than or equal to 300, and 2 is greater than or equal to 300. And this makes sense because this means that it's reasonable to conclude that there are at least 300 days out of the year that we could have picked from, which is a true statement. Our final condition is testing for normality, and we do this using the central limit theorem, which states that n1 is greater than or equal to 30, and n2 is greater than or equal to 30. Since both n1 and n2 are 30, this satisfies the central limit theorem, and we can conclude that it's safe to use T procedures. Now that JoJo has selected the 30 slips of paper randomly out of the hat, we have entered our data into our calculator. As you can see, we have L1 as the number of adults daily, and L2, each entry, is the amount of kids daily. So now I'm going to kind of describe our calculator procedure here. So we go to stat, arrow over to tests, and we're carrying out a 2-sample t-test. And since we already have all our data entered in L1 and L2, we simply have to calculate. And here we have everything we need. We have our t, our p-value, everything you need, your means, and your standard deviations.
This is a box and whisker plot of the distribution of the kids at the zoo. Here we can see the range is about 618 and the interquartile range is 300. There are also outliers, one at 254 and another at 872. The mean is 552.1 and the shape is relatively symmetric. And here is the distribution of the adults at the zoo. We can see that there is a spread or range of 884 and there are no obvious outliers. The mean is 1062.1 and the shape is relatively symmetric. In conclusion, since our p-value of 1.42 times 10 to the negative 12 is less than our alpha value of 0.05, we reject the null hypothesis.
And this means we have convincing evidence that the true population mean number of daily adult visitors at the zoo is greater than the true population mean of kid daily visitors at the Woodland Park Zoo.
So some people may think that we barely know stats, but we're actually really confident in our results of our study because when you think about it, a zoo is an activity where kids need a lot of adult supervision. So we think the ratio of kids to adults is outweighed by adults.
So for one of our confounding variables that we found for our project is that we had the survey done March, April, May, which are 3 months that kids are in school. So we thought, okay, maybe if we did it in summer, the conclusions would be a little bit different.
Sadly, our time at the zoo has come to an end.
I'm zooted.